The most feared fighter jet in the world just got deadlier. The F-22 Raptor, America's crown jewel of air superiority, is receiving upgrades so advanced they're classified. We're talking about technology that makes this already unstoppable machine even more invisible to enemy radar, sensors that can see threats before they even know they're being hunted, and weapon systems that will redefine air combat for the next decade. On January 22, 2025, Lockheed Martin received a $250 million contract that changes everything. The U.S. Air Force just approved the most significant F-22 upgrade in the aircraft's 20-year history. But here's what they don't want you to know. This isn't just an upgrade. This is America preparing for a conflict that defense experts say is coming sooner than we think. Welcome to Jet Insight, where we break down the military developments that matter most. What you're about to discover will show you exactly why America's enemies are losing sleep over these announcements. The numbers alone are staggering. Over $8 billion in improvements before 2030, new sensor technology that can track stealth aircraft, and fuel systems that extend the Raptor's reach across the entire Pacific theater. But the real shock isn't the money being spent. It's what these upgrades reveal about the threats our military is preparing to face. China's J-20 stealth fighters, Russia's advanced missile systems, and weapon technologies that didn't exist when the F-22 first took flight in 1997. Our Air Force isn't just upgrading a fighter jet. They're future-proofing America's air dominance against adversaries who thought they were catching up. The dedication of our airmen and the engineering brilliance behind these upgrades proves why America remains the global leader in military aviation. If you're proud of our Air Force's commitment to staying ahead of any threat, type Proud Eagle in the comments below. The infrared revolution. What changes everything? Let me tell you about the game changer that has enemy air forces completely rethinking their strategies. The Infrared Defensive System, or IRDS, represents the most significant advancement in fighter aircraft sensors since radar was first mounted on warplanes. On January 22, 2025, Lockheed Martin announced they received a $270 million contract to integrate this revolutionary system into our F-22 fleet. But calling it just infrared sensors doesn't capture what this technology really does. We're talking about a distributed network of tactical infrared search and track sensors, TAC-IRST, that gives every Raptor pilot superhuman vision across the electromagnetic spectrum. Here's what makes this so significant. Traditional fighter jets rely heavily on radar to detect targets, but radar signals can be jammed, spoofed, or detected by enemy systems. The new IRDS creates an invisible sensor web around each F-22 that can detect, track, and target enemy aircraft using their heat signatures alone. No radar emissions, no electronic footprint that gives away the Raptor's position. The system is so advanced, it can detect stealth aircraft that were designed to be invisible to conventional sensors. China's J-20 stealth fighter, which they've been bragging about for years, suddenly becomes much less stealthy when facing a Raptor equipped with IRDS. The heat from jet engines, even the most efficient ones, creates signatures that these new sensors can track from distances exceeding 90 kilometers. But detection is only part of the story. The real breakthrough is how IRDS integrates with the F-22's existing systems. Data from multiple TAC-IRST sensors gets combined with radar information, electronic warfare inputs, and data links from other aircraft to create what pilots describe as a three-dimensional battlefield picture that updates in real time. Justin Taylor, Lockheed Martin's vice president for the F-22 program, explained that this technology leverages their expertise in fifth-generation aircraft and air dominance systems to ensure uninterrupted U.S. air superiority today and into the future. When you hear defense contractors using phrases like uninterrupted air superiority, they're talking about capabilities that keep America's enemies awake at night. The timing of this upgrade isn't coincidental. Intelligence reports indicate that by 2050, adversaries will field anti-aircraft missiles with ranges up to 1,000 miles. China and Russia have already deployed new air-to-air and surface-to-air missiles, specifically designed to challenge American air power. The IRDS gives our pilots the ability to see these threats coming and respond before enemy systems can even detect the F-22's presence. What really sets this apart is the system's ability to cue weapons without using radar. An IRDS-equipped F-22 can detect, track, and engage targets in complete electronic silence. The first indication an enemy pilot gets that he's being hunted is when an AIM-120 AMRAAM missile goes active in its final seconds of flight. By then, it's far too late to react. Stealth evolution. Beyond invisible. Now let's talk about how the F-22 is becoming even more invisible than it already was. The fiscal year 2026 budget request includes $90.34 million specifically for what they call viability upgrades, and a significant portion focuses on enhancing the aircraft's low observable characteristics. We're not just talking about maintaining existing stealth capabilities. The Air Force is implementing next-generation technologies that make the F-22 harder to detect across multiple sensor types. Recent testing has included mirror-like coatings that reflect radar signals in carefully controlled directions, making the aircraft appear as nothing more than atmospheric interference on enemy screens. These stealth enhancements address a critical challenge that wasn't anticipated when the F-22 was originally designed. Modern radar systems use different frequencies and techniques than those available in the 1990s. China has deployed what they call quantum radar systems, while Russia has improved their VHF radar specifically to detect stealth aircraft. Our engineers have been working around the clock to ensure the Raptor stays ahead of these developments. The new stealth upgrades also improve what happens when the F-22 needs to carry external equipment. Traditional stealth fighters become much more visible to radar when they carry external fuel tanks or weapons. The solution involves redesigning how external equipment integrates with the aircraft's stealth profile. Enter the low drag tank and pylon system, one of the most ingenious engineering solutions you'll see in modern aviation. These aren't just fuel tanks that happen to be shaped differently. Each tank and mounting pylon is designed using advanced computational modeling to minimize radar reflection, while actually improving the aircraft's aerodynamic performance. When fully loaded with these new external tanks, the F-22 maintains stealth characteristics that are remarkably close to its clean configuration. But here's the really clever part. When combat requires maximum stealth and performance, the tanks and pylons can be jettisoned in a way that leaves the wing surface smooth and optimized for stealth operations. The engineering challenges involved in creating this capability are staggering. The attachment points need to be strong enough to handle the stresses of supersonic flight, while being able to separate cleanly when needed. The tanks themselves must be shaped to complement the aircraft's stealth profile, while holding enough fuel to extend combat radius significantly. Flight testing completed in 2024 demonstrated that F-22s equipped with these new tanks can fly supersonic missions that were previously impossible without aerial refueling. For operations in the vast Pacific theater, this capability transforms how the Air Force can project power and respond to threats across thousands of miles of ocean. Sensor fusion, the billion-dollar eyes. The scale of sensor improvements goes far beyond just infrared capabilities. RTX's Raytheon division received a contract worth up to $1.045 billion to completely revolutionize how the F-22 sees and understands the battlefield. This isn't just an upgrade, it's a complete reimagining of what a fighter aircraft can perceive and process. The contract, announced on August 29, 2024, covers what's officially called the F-22 Sensor Enhancements Program. Work will be performed at Raytheon's facilities in McKinney, Texas, with completion expected by May 8, 2029. But the timeline tells you something important about the complexity involved. This isn't just swapping out old sensors for new ones. We're talking about integrating sensor systems that didn't exist when the F-22 was designed. Modern electronic warfare environments are incredibly complex, with multiple aircraft, ground systems, and even satellites all transmitting and receiving signals simultaneously. The new sensor suite has to make sense of this electromagnetic chaos and present pilots with clear, actionable information. The cornerstone of this upgrade is an advanced infrared search and track system that goes far beyond the IRDS we discussed earlier. While IRDS focuses on defensive capabilities, the new IRST provides offensive targeting capabilities that rival or exceed anything currently flying. The system can detect aircraft at ranges exceeding 130 kilometers and maintain track even in heavy electronic jamming environments. But detection range is only meaningful if you can act on that information. The new sensors integrate with updated mission computers that process targeting data faster than any previous fighter aircraft system. When an F-22 pilot identifies a threat, the time from detection to weapon release can be measured in seconds rather than minutes. The implications for air combat are profound. Modern air-to-air engagements often come down to who detects the other first and can employ weapons most quickly. These sensor upgrades give F-22 pilots what amounts to a significant head start in any engagement. By the time enemy aircraft detect the F-22's presence, American pilots have already analyzed the threat, selected appropriate weapons, and begun engagement procedures. Intelligence sources indicate that the sensor improvements were specifically designed to counter advanced aircraft like China's J-20 and Russia's Su-57. Both of these aircraft incorporate stealth technologies, but they also have specific electromagnetic signatures that the new F-22 sensors can identify and track. Electronic warfare dominance. Electronic warfare capabilities represent another crucial area where the F-22 is receiving significant upgrades. Modern air combat isn't just about who has the fastest jet or the longest range missiles. It's increasingly about who can control the electromagnetic spectrum. The upgraded electronic warfare suite gives F-22 pilots the ability to jam enemy radars, disrupt communications, and even feed false information to adversary sensor systems. When an enemy radar tries to lock onto an upgraded F-22, the aircraft can respond with electronic countermeasures that make it appear to be in a completely different location. These capabilities become especially important when facing integrated air defense systems. Countries like China and Russia have developed sophisticated networks that link ground-based radars, surface-to-air missiles, and fighter aircraft into coordinated defense systems. The F-22's new electronic warfare capabilities can disrupt these networks, creating gaps that allow American forces to operate with reduced risk. The system also provides what's called electronic attack capabilities. This means the F-22 can actively degrade enemy sensor and communication systems, not just defend against them. An F-22 operating in electronic attack mode can effectively blind enemy radar systems across a wide area, creating opportunities for other American aircraft to complete their missions undetected. Weapons integration. Next-generation firepower. The weapon systems being integrated with these upgrades represent the cutting edge of air-to-air combat technology. While much of the information remains classified, we know that F-22s are being prepared to carry the AIM-260 Joint Advanced Tactical Missile, or JATM. The AIM-260 represents a significant leap forward in air-to-air missile technology. Developed specifically to counter advanced threat aircraft at very long ranges, this missile gives F-22 pilots the ability to engage targets well beyond the range of enemy weapons. When facing aircraft like the Chinese J-20, this range advantage can be decisive. The missile's development was directly influenced by the Chinese PL-15 air-to-air missile, which intelligence assessments suggested posed a significant threat to American aircraft. The AIM-260's capabilities ensure that American pilots maintain a decisive advantage in beyond visual range combat scenarios. Integration of the AIM-260 required modifications to the F-22's internal weapon bays and fire control systems. The missile's advanced guidance systems can receive targeting data from the aircraft's upgraded sensors, creating a weapon system that can engage multiple targets simultaneously across different ranges and altitudes. Flight testing has demonstrated the missile's ability to successfully engage targets when cued by infrared sensors alone, without requiring radar emissions that might alert enemy aircraft. This capability is particularly valuable when operating in contested environments, where maintaining stealth is critical. Pilot interface revolution. The human element in all these technological advances centers on how pilots interact with these incredibly sophisticated systems. The next-generation fixed-wing helmet program represents a complete redesign of how F-22 pilots receive and process information during combat operations. The current helmet system used by F-22 pilots is based on technology that's over 40 years old. While it has served admirably, modern combat environments demand capabilities that simply weren't imagined when the original system was designed. The new helmet integrates seamlessly with all the upgraded sensors and weapon systems we've discussed. Pilots wearing the new helmet system can see targeting information, threat warnings, and navigation data projected directly onto their visor. More importantly, they can designate targets and control weapon systems using head movements and eye tracking. This reduces the time required to engage threats and allows pilots to maintain situational awareness even during high-stress combat maneuvers. The helmet also integrates with the aircraft's electronic warfare systems, providing pilots with real-time information about enemy radar and communication activities. When facing sophisticated adversaries, this information can mean the difference between mission success and failure. Lift Airborne Technologies received the contract for this helmet system in 2022. And testing has proceeded ahead of schedule. Pilots who have evaluated the system describe it as transformational, providing capabilities that significantly enhance their effectiveness in complex combat scenarios. Pacific Theater Focus. The strategic context driving these upgrades becomes clear when you examine where F-22s are being deployed and how they're being used. The vast distances involved in potential Pacific conflicts require capabilities that simply weren't necessary when the aircraft was originally designed for European scenarios. F-22 Raptors have recently been deployed to Japan, replacing older F-15C Eagles in a clear signal of America's commitment to maintaining air superiority in the region. The upgraded fuel systems and extended range capabilities directly support this mission, allowing F-22s to operate across the entire Western Pacific without requiring forward bases that might be vulnerable to enemy attack. The basing strategy also reflects lessons learned from recent conflicts. Forward operating bases can be targeted by long-range missiles, potentially limiting aircraft availability when they're needed most. F-22s with extended range capabilities can operate from more secure locations while still maintaining the ability to respond to threats across the entire theater. Intelligence assessments suggest that China's military modernization specifically targets American air power projection capabilities. The F-22 upgrades represent a direct response to these challenges, ensuring that American pilots maintain decisive advantages regardless of how adversaries adapt their strategies. Community message. Before we continue exploring the incredible engineering behind these upgrades, I want to take a moment to recognize the veterans and active service members who might be watching this. Your service and sacrifice make innovations like these possible, and your expertise helps ensure these systems are developed with real-world combat experience in mind. If you're a military veteran, current service member, or military enthusiast, you're part of a community that understands the importance of maintaining technological superiority. We'd love to have you join our community of people who share your passion for military aviation and defense technology. Manufacturing and production challenges. The scale of implementing these upgrades across the entire F-22 fleet presents significant manufacturing and logistical challenges. With 185 F-22s in the Air Force inventory and 143 of those designated for combat operations, the upgrade timeline requires careful coordination to maintain operational readiness while aircraft are being modified. The Air Force has developed what they call a rolling upgrade strategy, where aircraft are taken out of service in small groups for modification, while the remaining fleet maintains operational capabilities. This approach ensures that F-22 squadrons remain ready to respond to threats even during the upgrade process. Lockheed Martin's Marietta, Georgia facility serves as the primary location for major modifications, while Raytheon's McKinney, Texas operations handle the sensor upgrades. The coordination required between these facilities, along with numerous subcontractors, represents one of the most complex aircraft modification programs ever undertaken. Quality control for these upgrades requires testing standards that exceed those used for new aircraft production. Every modified system must not only meet original specifications, but also integrate seamlessly with new capabilities. The testing protocols include flight testing, ground testing, and simulation work that validates performance across all possible operational scenarios. Cost and budget realities. The financial investment in these F-22 upgrades represents one of the largest aircraft modernization programs in Air Force history. The total commitment of $7.8 billion through 2030 includes $3.1 billion for research and development and $4.7 billion for procurement and implementation. When you break down these numbers, the cost per aircraft for the complete upgrade package approaches $45 million per F-22. While this might seem expensive, it's significantly less than the cost of developing and producing a completely new aircraft with equivalent capabilities. The budget allocation also reflects the reality that the F-22 production line was closed in 2012 after only 187 aircraft were built. Originally, the Air Force planned to purchase 750 F-22s, but budget constraints and changing priorities resulted in the much smaller fleet we have today. These upgrades ensure that each aircraft in the current fleet can perform missions that would have required multiple aircraft with older technology. Congressional support for the upgrade program has been strong, with both defense committees recognizing the strategic importance of maintaining air superiority capabilities. The program enjoys bipartisan support, reflecting widespread recognition that these investments are essential for national security. Future implications and NGAD integration. Perhaps the most intriguing aspect of the F-22 upgrade program is how it serves as a technology demonstrator for the next-generation air dominance program. The sixth-generation fighter system, recently designated as the F-47, will incorporate many of the technologies being tested on upgraded F-22s. The sensor fusion capabilities, electronic warfare systems, and pilot interface technologies being implemented on the F-22 will directly inform the design of future aircraft. This approach allows engineers to validate new concepts in operational environments before committing to production programs worth hundreds of billions of dollars. The F-22 is also serving as a testbed for manned-unmanned teaming capabilities. Future operations will likely involve fighter aircraft working closely with autonomous systems, and the upgraded F-22s are being prepared to serve as command platforms for these collaborative combat aircraft. This role as a bridge between current and future capabilities ensures that the F-22 upgrade investment provides value well beyond the aircraft's operational lifetime. Lessons learned from these modifications will influence American air power for decades to come. Global response and strategic implications. The announcement of these F-22 upgrades has not gone unnoticed by America's potential adversaries. Chinese and Russian military publications have already begun analyzing the implications of these capabilities, with particular attention to how they might affect regional power balances. China's response has included accelerated development of their own sixth-generation fighter programs and increased investment in air defense systems. However, the technological gaps revealed by the F-22 upgrades suggest that American air power maintains significant advantages that will be difficult to counter. Russia's reaction has been more muted, largely due to economic constraints that limit their ability to respond with equivalent programs. However, Russian engineers are certainly studying these developments and adapting their strategies accordingly. Allied nations have expressed strong support for the upgrade program, recognizing that American air superiority benefits the entire network of democratic nations. Several allies have requested briefings on how these capabilities might integrate with their own air forces during joint operations. Testing and validation progress. The extensive testing program supporting these upgrades provides confidence that the new capabilities will perform as designed in operational environments. Flight testing conducted in 2024 included 6 successful test flights, specifically focused on the new sensor systems. Edwards Air Force Base serves as the primary location for F-22 upgrade testing, with the 411th Flight Test Squadron leading most of the evaluation work. Their pilots bring extensive operational experience to the testing program, ensuring that new capabilities are evaluated from a realistic combat perspective. The testing program also includes extensive simulation work that models performance against potential threat systems. These simulations use intelligence data about adversary capabilities to ensure that upgraded F-22s will maintain their advantages even against the most advanced enemy systems. Ground testing has validated the reliability and maintainability of new systems, addressing concerns about how these sophisticated technologies will perform in operational squadrons with standard maintenance procedures and equipment. Operational impact. The real measure of these upgrades will be their impact on operational capabilities and pilot effectiveness. Early feedback from pilots who have flown aircraft with preliminary upgrades indicates significant improvements in situational awareness and combat effectiveness. The sensor upgrades provide pilots with information quality and quantity that far exceeds anything previously available in fighter aircraft. Pilots report being able to track multiple threats simultaneously while maintaining awareness of friendly forces and mission objectives. The extended range capabilities fundamentally change how F-22s can be employed tactically. Missions that previously required aerial refueling can now be flown with internal fuel alone, reducing complexity and improving mission security. Electronic warfare capabilities give pilots tools for dealing with sophisticated enemy air defense systems that would have been extremely challenging to counter with older equipment. The ability to operate effectively in heavily contested environments opens up tactical options that weren't previously available. Conclusion: the F-22 Raptor upgrade program represents far more than just modernizing an aging aircraft. These improvements ensure that America maintains decisive air superiority advantages well into the future, while serving as a foundation for next-generation capabilities that will define air power for decades to come. The $8 billion investment demonstrates America's commitment to maintaining technological superiority over any potential adversary. More importantly, it shows our dedication to ensuring that American pilots have every possible advantage when they're called upon to defend our nation and allies. The engineering brilliance behind these upgrades reflects the best of American innovation and manufacturing capability. From the sensor technologies that can see targets other aircraft can't detect, to the stealth improvements that make an already invisible aircraft even harder to find, every aspect of this program pushes the boundaries of what's possible in military aviation. As these upgraded F-22s begin entering operational service, they will serve as a powerful deterrent to any nation that might consider challenging American interests or threatening our allies. The combination of proven F-22 capabilities with cutting-edge new technologies creates an air superiority platform that will remain unmatched for years to come. The men and women who fly and maintain these incredible machines deserve our respect and gratitude. Their skill and dedication, combined with these technological advances, ensure that American air power remains the global standard for excellence and effectiveness. If this breakdown of America's most advanced fighter upgrades impressed you as much as it should, make sure to hit that like button and subscribe for more in-depth coverage of the military technologies that keep our nation safe. The innovation never stops, and neither do we.